example 3, like the first thing that I had you look at, what did it have you do? Somebody describe it to me. Raise your hand if you can describe it to me. Colby, describe it to me.
I didn't take the notes. I apologize.
Okay. Well, you were encouraging Grace, so I thought maybe you. If we have something like this, instead of doing a Riemann sum, or really what the next thing I'm going to show you, what can we use? What could we do? We can use geometry, okay? We have a horizontal line, and we are taking the integral from 1 to 4. Well, that is essentially the area of a rectangle. So instead of actually doing any Riemann sums, or what I'm going to show you with integration, we could just say, okay, we have a rectangle that has a height of 2 and a width of 4. Our area is 8. What other shapes can we take? Can we find area of? What? Trapezoids, what else?
Circle.
Circles, triangles, right? And that's probably not going to happen, but good try. Okay, here with a linear equation, if we have a linear equation that has slope, we've created a trapezoid. Or, as Sean sees it, a triangle and a rectangle. Does it matter? No. This rectangle has area 3, and that triangle has area 9/2. So the area under the curve would be
7.5.
okay. Okay. I need you to write this down because you need to be able to recognize that that is a semicircle. You know that x squared plus y squared equals r squared is a circle. So if we solve for y, we have the square root of r squared minus x squared. You need to be able to recognize that that is a semicircle. If it were to be negative, then you'd have the bottom half of the semicircle. When it's positive, you have the top half of a semicircle. Okay. But since we're only going from 0 to 1, how much of the circle are we actually calculating the area of?
Quarter.
We have a quarter circle. So when we calculate the area, the integral from 0 to 1 of this semicircle, we're talking about 1/4 pi r squared. Okay. Where I see you using this the most often would be if you have a semicircle or an absolute value. Have I ever shown you how to take the integral or even the derivative of an absolute value? No. So if I were to give you the integral of the absolute value of x from 2 to 3, then that is something that you would need to graph and calculate the area using geometry. Okay? There is no way for us to do this problem other than graphing it and using geometry. Okay? Now, in our problem of the day, we had negative area. Some of you panicked. I got the wrong answer. You're right. How is it possible to have negative area? Well, when we actually take the integral with limits of integration, so when we have a definite integral, we are calculating the area from the curve to the x-axis. So if we have a situation where we have negative area, it is because we are underneath the x-axis. Because the x-axis is on top of where our curve is. Probably. I'm guessing you didn't take these notes last night, right? Well, Chloe didn't take any of them, but.
Ow. Dang.
You are probably right. Okay, so anytime we find area under the curve, above the x-axis we're going to have positive area, below the x-axis we're going to have negative area. Okay, so, oh, I thought you said hold on.
I'm tired.
I'm sorry. So if we have something that looks like this, okay, what would we say about the integral from a to b of f of x? Say it louder, Aaron. It would be 5. From a to b, this has an area of 5. So the integral from a to b of f of x dx would be 5. What about the integral from b to c of f of x? Okay, this portion from b to c has area of 4, but it's underneath the curve. So the integral, calculating the area, would be a negative 4 because it's underneath the x-axis. Okay, I'm going to bore you one more time. C to d. The integral from c to d of f of x dx is calculating the area under the curve from c to d, which would be what? So what if I asked you about the area from A to D of f of x? Yeah. What? You add them all. So from A to B we have 5, from B to C we have negative 4, from C to D we have 3. So total we have an area of 4. What do you think? Not too bad? Good. Why are you guys freaking out? Okay, did we just not talk about using simple geometric figures to help you calculate area? So what I would ask you to do is draw this accurately in your notes. You think 30 seconds is enough time for you to finish?
This one? Thank you. Pretty accurate.
All right. How many different calculations are we going to have to make? I would say 4. Our first calculation is going to have to come right here. This area right here. We have a triangle, right? And where is it sitting? And underneath the curve. So we have negative the area of that triangle. 1/2. The base is 1, 2, 3, 4, 5. The height is 1. What did you say? Right? Yep. Okay. Next, what do we have?
Semicircle.
We have a semicircle above the x-axis. What's the radius of that semicircle? So we have 1/2 of pi r squared. Okay. Okay. Next. This is a triangle above the x-axis. So 1/2, we have a base of 5/2 and a height of 3. And then down here, since we dip below the x-axis, we have to do this guy separately. We have one itty-bitty triangle below the x-axis. So we're going to have to subtract 1/2 base times height. So we have an exact area of 2 pi. Plus what? Huh? These 3 add up to be 1? Somebody want to just double check? Yeah, we've double checked? Nice. You just trust him, you didn't check him?
No, I did it.
Oh, okay.
That was cool.
Oh, that was Colby. Okay. He's sitting right in front of you, so it sounded good. Okay, so when you were to, okay, so first of all, do we have any questions here? If you're given a graph, this is a piecewise graph, right? You're given a piecewise graph, piece together different geometry shapes until you get your curve. Anything underneath of the x-axis is negative, anything above is positive. We're doing 2 lessons today, remember? Because of our snow day. Here are the properties, some of which you wrote down yesterday in your notes. You wrote down the top one? What else did you write down? We wrote down the second one, okay. All of them? Okay. I was hoping that would work out. So let's just talk about these. Okay, so some of them are kind of common sense. So that first one, the integral from A to A, the area under the curve from A to A, 0. Well, it's nothing. You don't go anywhere, right? Okay, the integral from B to A equals the negative integral from A to B. So if you go backwards, we're talking about negative area of the original. Like B to A would be backwards. So it's negative the integral from A to B. Okay? This third one, the integral from A to C plus the integral from C to B, means we can squish them together and be the integral from A to B. Guess what? We've already been doing that with the last couple examples.
They should have made the big one A to C. It tripped me up for like.
I
5
understand
days.
your concern. I agree.
It really
Okay.
bothered me.
And then these right here, if we add or subtract inside of our integral, we can break it apart and add and subtract multiple integrals. The same way, if we have a constant inside, we can throw it outside of our integral. If you took your notes from last night, as per my specifications, you should have written all these down. You like them all in one place.
No.
I am not sure Grace has ever come without doing
Who won? Who won?
it. Eli Warner.
Almost.
Flat out said out
Okay.
loud.
Sorry to pick on you, Grace, but I'm trying to verify that we're all pretty sure that you did your work. Okay. So the problems on our next slide should be some like relief problems. I think they don't take very much work, which some of you really like. Okay, especially after yesterday, right?
Yeah.
I see a couple of pencils still moving.
It's nice to have. Oh, I could draw a T stop sign.
Write these two down, and then we are going to wrap up lesson number 1 of the day, and lesson number 2 I'm going to make very short. Okay? I mean, I have to, but I warned you this was going to happen, but we're going to make it through. Next week will be better. As long as you have what?
Oh my gosh, somebody's gonna sing for me.
It's messing up my
What?
I don't want that.
I know there's supposed to be some weather on Tuesday night.
Yeah, that's what I was.
Okay, so given these two, I want the integral from 0 to 7. Well, I gave you the integral from 0 to 5, and then I gave you the integral from 5 to 7. So what do we do?
Add them up. I like those ones.
How about this one? The integral from 5 to 0 of f of x dx. If the integral from 0 to 5 is 10, then the integral from 5 to 0, oops, that way. You're going backwards.
But it's
It's above, but you're going backwards. Like we go from left to right with our area. But it's like we're reading backwards.
it just seems like it's
It's not. Okay. Some people are not liking this one. When we find area, we start at the left and go to the right. That's how we read, right? Well, if we start at the right and go to the left, we are going backwards. We're going in the negative direction. And so any area becomes negative, even if we're above the x-axis. Okay? What's the integral from 5 to 5? That's like the easiest question on the test, okay? What?
So this is on the one.
I mean, it will be some of it, yeah. Last one, and then we'll move to the fundamental theorem of calculus. No, it's really called that. But I didn't emphasize fun.
Is it really fun?
I think you would like it better than Riemann sums. Okay. The integral from 0 to 5 of f of x, we have, right? But there's a 3 thrown inside. So throw the 3 outside. You can do it in your head. What? These won't be on the rule quiz, but I'm hoping this part of the test is where you like buffer some of your points. What?
Where we actually make our grade. Like those easy mob questions.
Like one of the games was like fuel cells. It's like it's a physical science class.
In function. Well, I emphasize it in the fundamental theorem of calculus. Write the beginning part, and then I'm going to blow your mind. All of that work with integrals, and we still have yet to do antiderivatives for the past 2 weeks, basically. Right? Don't you want to do an antiderivative again?
No.
Okay, would you like to continue to do Riemann sums?
Yes.
Those are wild.
By the way, we still have 3 more rule quizzes that could replace your first rule quiz score. Obviously, we didn't have time today, but we will have time next week. Hint, hint, wink, wink. Make sure you know those. I don't know which day, but there has to be multiple.
Is there any adding to it?
Don't remember.
What rules?
I have them up here. I'll try to hand them back. So, the integral from A to B of f of x dx is the antiderivative evaluated at B minus the antiderivative evaluated at A. Done. I'm serious right now.
It looks easier.
So do we have to check if that is
What?
do we have to check if that is
Well, I mean,
I probably think that I meant tangent
okay, now what's nice about this is you don't have to worry about plus C. Why? Okay. If I give you a function and you take the antiderivative plus C, what you have to do is you have to evaluate your integral from A to B, okay? So if you take f of B plus C and then you subtract f of a plus c, what happens? Those plus c's cancel out with each other. So if you have a definite integral, you do not need to worry about your plus c, because they're going to go away when you evaluate it. Huh? So you don't have to write plus c when you take your antiderivative. That is what I'm telling you. On definite integrals. That quiz, are there any numbers on your integration sign? Then you need the plus c still for those. Okay? Write this down. Integral from 0 to 1 of 3x squared plus 2 dx. What does that represent? We just spent the past couple days talking about how it represents the area under the curve from 0 to 1. But instead of doing a Riemann sum, we obviously can't do a geometric shape. We can take the antiderivative. The antiderivative of 3x squared is x cubed. The antiderivative of 2. We're going to take that and evaluate it from 0 to 1. That's that line, evaluate. Okay, so we don't forget about our limits of integration. So what we're going to do is we're going to plug in the top number first, 1 cubed plus 2 times 1. And then we'll subtract the bottom limit of integration. For a grand total of, Math 9 will verify that that is the correct answer. Math 9? Not Tech 9, Math 9. Really, don't know Tech 9.
Don't start
Probably should. There are. Okay. Next one.
That's the first I thought, to be honest.
What to do with the other one? Like area? Like exact area? So basically, if you have any sort of straight lines or a semicircle, you can use geometric shapes, but any sort of curve, you're out of luck. You're going to have to do this. Okay? So this is 3 times x to the 1/2. What is its antiderivative? Well, it'd be 3 x to the evaluated from 1 to 4. So we're going to take 2 times 4 to the 3/2 minus 2 times 1 to the 3/2. Plug in your top limit of integration minus plug in your bottom limit of integration. 4 to the 3/2 is 8 times 2, 16 minus 2 is 14. Math 9 will verify that we have the right answer. Okay, you asked a great question. Eli asked, do we ever have to do one of those big sum things again? I will ask you to do the Riemann sum one time on next week's quiz and one time on your unit test, and then you are done with them.
Forever.
It won't be.
Oh. All right, let's do this one. It's always good to practice trig. This one and then one more example. And then we'll be done with our 2 lessons.
Why is there no X?
Oh, why is there no X? I don't know.
That's a really good snack.
Yeah. Caught that with my bare
Cosine. They're integrating. What is our antiderivative?
Negative.
Negative or positive?
Sign.
We need to evaluate it from 0 to pi, which means we plug in our top limit of integration minus we plug in our bottom limit of integration. What is it? The sine of 0 is 0 and the sine of pi is 0.
0.
Yes.
It's a line.
What?
Ah. What does the cosine curve look like?
All the way up.
It's the one that starts with now.
Okay, it looks like a valley, but if I stop it at pi, it looks like this. So Nicole said, well, the area here is going to cancel out with the area here because we have symmetry, right? Positive area, negative area.
It doesn't?
No.
Was that our second lesson?
That was our second lesson, yes.
Oh, so
No, there's 2 minutes left and we're going to do another one.
Okay.
Okay, we might not get all the way through this problem, but I'd like to remind you how to attack this because it's been a few weeks since we've actually done integrals because of our 4 snow days
Rewrite it.
and 3-day weekend with Okay, Colby, how would I rewrite x over radical x?
X minus 2 times, wait,
Yeah, keep going though,
that quantity times x to the 1/2, right?
Well, x to the negative 1 half.
Negative 1.
But then you would need to go one step further and write it as x to the 1/2 minus 2x to the negative half. So that you had individual terms where you could use the power rule.
Yeah, you mean like distribute?
Yes.
Yeah, okay.
Yes.
Sorry.
Just wanted to make sure we were all on the same page. Okay? Okay. I don't like teaching bell to bell on Friday any more than you like sitting there and doing it, but with our snow days, there's really not a lot I can do. So, I am sorry, but you have 2 homework assignments over the weekend. I will make it up to you somehow.
Cookies.
Brown lights.
Oreo balls.
I am not the Oreo ball master.
Some sort of dessert.
Anthony Boo makes Oreo balls like a champion.
Who does?
Right? No, Riker eats whatever. It is, he always wants to do it. But. All right, enjoy your homework-filled weekend.